Assalamualaikum warahmatullahi wabarakatuh. We are from Group 1 and we will present about square root of an integer. Before we get into the presentation, we should introduce ourselves first. Hello, my name is Destry Sulistyowati.
My name is Muhammad Najwan Sulvadli.
My name is Jason Iskandar Syakir.
After 12 years of going to public school, the authors remember one of the teachings that the authors learned from mathematics, and that is square root. Square root in mathematics, a factor of a number that when multiplied by itself, it gives the original number. For example, both 3 and minus 3 are square roots of 9. After remembering about square root, the authors begin to search about it. Since the authors thought, isn't it easier to calculate square root by making a program to calculate it? What we found is, as early as the second millennium BC, the Babylonians possessed effective methods for approximating square roots. This method is called by Babylonians method for finding square roots, or sometimes Hero's method. It was known long before Newton invented this general procedure. That's why in this paper the authors will explain about how to apply the Babylonian method to calculate square root of an integer.
Next is basic theory. Definition of algorithm. A finite sequence of instructions, each of which has a clear meaning and can be performed with a finite amount of work in a limited amount of time, is how an algorithm is defined. As a result, an algorithm must be precise enough for human to understand. However, in order to a computer to run a program, it must be written in a strict formal language, and because computers are rather inflexible in comparison to the human mind, program must typically contain more information than algorithms. Algorithm can obviously be described in layman's terms, and we will do so on occasions. However, it is actually easier and clearer for computer scientists to use something that is midway between formatted English and computer program code. But it is not runnable due to missed features. This is known as pseudocode, and it can take many different forms. Frequently, these notes will present pseudocode segments that are quite comparable to the language we are not most interested in. Notably, the overlap of C and Python with added benefit of being easily incorporated into executable application. Next is square root of integer. The calculation for square root were first discovered in the Rhind mathematical papyrus in c. 15th century BC. Ancient Indian mathematicians used square root in their work hundreds of years later, between 900 and 40 BC. The square root symbol was first used in the 16th century in Europe. According to mathematical historians, the symbol is a modified version of the Latin root radix. When n is a negative number, the root is called imaginary. Customarily is designed by it so that the square root of any negative number can be expressed as ai, where is a real number. Where I is a real number. Okay. As I result, there are many ways to solve this problem, and one of the method is using the Babylonian method.
Next is problem analysis. So, there are three problem analysis. The first is Babylon method. The second is algorithm of Babylon method. And the third is the example of the Babylonian method. Okay, the first, why is Babylonian? So, there was an old Babylonian mathematics by people of Mesopotamia that developed and practiced mathematics. Most clay tablets that describe Babylonian mathematics belong to the Old Babylonian, which is why the mathematics of Mesopotamia is commonly known as Babylonian mathematics. Some clay tablets contain mathematical lists and tablets. Others contain problem and work solution, like arithmetics, algebra, growth, and square root. And as the topics today, we explaining the root computation by Biblion mathematics, which were among the first used root computation in the world, and also the first algorithmic technique developed in mathematics. Next, the algorithm of square root method by Biblion mathematics. The algorithm of the square root method is 1. Begin with arbitrary positive number starting value as n. As the closer to the actual square root of n, the better it is. Then, let the xi plus 1 be the average of n per xi plus xi. Repeat the step 2 until the xi is equivalent with n. As you can see, this is the formula of the algorithm. And the last is the example of the Babylonian method. Okay. If we want to find the square root of 2, starting with x equals 1, the second estimate will be 1.5. Then, repeat the calculation with x equals 1.5 to get the third value. That will be 1.41666 and so on. Then, repeating the method, the fourth value will be then 1.414215 and so on. So, the each new value in the succession is closer to the square root of 2, or 1.414215 and so on. And it seems the method is converging to the desired root. And this is the code implementation. To find the floor of square root, try with all natural numbers starting from 1. Continue incrementing the number until the square root of that number is greater than the given number. So the code is, firstly, make function floor square root with x as the argument, then define the base cases. If x equals 0 or 1, it will return the x. Then define I is 1 and the result is 1, 2. So, it will starting from 1 and try all number until I multiplied by I is greater than equal to x. After the result greater than or equal to x is false, then the function return I minus by 1 as the answer of the square root of integer.
Thanks for watching. Wassalamualaikum warahmatullahi wabarakatuh.